Hello everyone, welcome to another stream. How are we all doing? Right. So, what was that? Last stream, we got the, where is it? We got this shader working fully. Well, at least we think we did. Where we generate all 8 LODs for this cluster tree. So we generate all the spheres for each LOD. Well, okay. All the spheres for each LOD which has been specifically painted down for that LOD. We don't generate the lower level detail spheres yet in the cluster tree. So now we're generating this thing called an occupation map, which is basically just a bit set where each bit represents a cluster of 2x2 spheres, which has every sphere which is completely filled, right? So here is the occupation map. We got it working. So we're meant to be painting down a sphere in the middle. Well, okay. So we're using like an ellipse to paint into this sort of space, this 3D space. And I'm going through the slices here. And as I go into it, you see the sphere that we're painting down start to appear, right? But it's only appearing in this part here, this top left area, which I think is the bottom left in my coordinate system, but obviously it's flipped in render doc here. Hey there, Pain, how you doing? Yeah, I'm doing well, man. Doing well. Hope you're doing good too. Yeah, it's been busy, you know. So, what's interesting is anything past the near. So this is in the highest level of detail. Anything in the near left bottom, shall we say? I know it's at the top, but it seems to paint in it. But as we go past the halfway point on the Z, ready? And it disappears. Wait for it. There you go. Okay. So when we see this slight, so there's something really weird that's going on. So we're just going to investigate that. So the way we're going to investigate it is basically move this thing we're painting down to up here, right? And then we'll do some printing to debug and see what's going on. So it's quite easy to do that. So the volume is 256 cubed. So we simply just move it. Wait a minute. Yeah, 64 in. Okay, so if I moved it 64 less, let's just see how it behaves. And we'll make it 32 big. So we should see something in there. It should be fully contained within that. We should be able to see the full sphere, basically. So we give it another launch. Do a capture. We're going to go ahead and pull out here's the clear image, here's the occupation map building shader. So as we move through the slices, we should see this, there it is. It's in the sphere, right? Excellent. So we're seeing it in its full, I'm going through all the slices here because it's a 3D texture, and we're just seeing it emerge and then disappear. So remember, each bit in this bit set represents a cluster which is filled with spheres. That's all it is. And see here how we've got 56 on that pixel, which means not all of them are on. Yeah. Oh. Interestingly, a really big value. Right, of course it'll be like 4 billion or whatever. This range thing is... You know, I guess I can set that to like 4 billion or whatever still. There you go, so you see something better, right? So you see in here how these are partially filled bits. So it seems like it's working. So that's cool. But it doesn't work when I move it into the... So this is like the lower left near quadrant, if you would say it. Like it's an eighth of the area, right? So if I move it, there we go. Let's move it. Okay. Maybe we should keep it near. I'm gonna keep it near. There we go. So I've just moved it to the right and back. Sorry, to the right and up. And I've kept it kind of in the near. So we won't see anything in the texture, and this is the bug, right? We're not seeing it in these sort of the right quarter. We're only seeing it in the top left quarter, whatever it is. It's kind of mirrored along the Y. So if we just have again, why not seeing a thing? Oh, I don't think it's writing to a texture at all, because it's not showing up in the texture viewer, the outputs. So it's actually not writing. Interesting. So it must be to do with the generation then. So should we see the debug print code? All right. So not seeing anything here. Are we supposed to be? So let's go up to the generation code. So a whole bunch of print statements in here. Let's have a look to see what we got, right? Right, so let's enable this one. This one's going to say show nodes that we allocate. Oh, yeah, let's just start there. See if we allocate any nodes. This just gets printed from the shader and we'll say, hey, this node got allocated. We should see some at least, right? Right, so we see a few. We only see on the first level. So how this reads is, so on the first LOD, we generate node 1. Yeah, so node 0 is the root node. And it allocates a child 3, and because there's 8 children in a node, and it generates it at LOD 1. So in the next iteration, 7 get made, right, which makes sense. We don't seem to carry on past there, which is weird. And these will make one in the next LOD. So it completely fills an area. So if we go into Milton, we've got the drawing, so we can kind of show another perspective on what this means. There's this one which I like to go to, right? So LOD 0, this is node 0, right? Which you see in the comment you see here. And we allocate child 3. So there's 8 children, and we're only seeing 4 here because it's 2D. So this one gets allocated here, this lower right, this, well, something like that, right? This one. No, wait. We're putting it top. Yeah, so it'd be this one here gets allocated on the near. So it allocates this guy. This one will be child or node 1 at LOD 1, right? And then we go down again. And then the edit that we've put down. So we've just put down an ellipse here to say, hey, we're painting this area. And what happens is obviously in this LOD, the ellipse covers this whole space here. So all of these guys get painted down, including the ones behind it. But then it just stops there. And I don't know why. So we're going to enable some more printing, right? So the next one to enable will be this one. So just saying, hey, we're generating this node. So we generate node 0 at this place, and then we allocate these guys, generate this one, and then we never generate any more. That's very fishy. So the other one, so something happens. See, it could be the collision code. Where we're doing this collision test. It is a little bit wrong, but oh. Now here we go. So this is all the data work. So we've got this sort of ellipse that we're painting down to that 3D space, and it's checking against all those guys. Got a nice lemonade here. Open this boy up. So it says we have intersected it, right? Oh, then we produce these boys. Right, but we never see anything else past here. So I feel like, okay, it's nothing to do with this code. It's something to do with that traversal code. And also, I've been thinking about this thing. And like, we don't really have to traverse down this tree like this. We could just cache in a 3D texture. And that would probably save some time on the generation. But what else? Yeah, it depends. Yeah, we can definitely change how this works, but for now, I guess we can just leave it, get it working. So this is at the start of the shader when we generate the leaf spheres. We basically traverse on the tree until we find the node which this thread is referring to, and there's a group of 8 threads which are together, which land on the same node, and each thread targets a sphere within a node. So just goes down and finds it. But yeah, anyway, so I think there's something to do with these guys which gets buggered up a bit. So we're just gonna turn these on, and these will give us even more verbose idea of what is going on. Right, stop no child is probably a bit of a let's disable that one and see if that one is the one. Right, it is the stop no child one. Okay. So apparently there's no child there. So it goes down. The thing is, we've got to stop it at a certain. We should stop it because it's just going to debug print so much stuff. You know what? Let's just print out the bit set. See what it thinks is there. Oop. So what 8? So there's only one child that's set. Going down from 0? No. I'm skeptical there. Okay, so let's wind back a bit. So if we're painting down at 7 in this space, let's bring the max LOD down to 1. So 2. So this is where we was getting stuck. We couldn't generate 2 for some reason. Excellent. So now we're getting the information at a minimum. So right, this seems okay. Because there's only the 3 missed. Okay, we'll see. So we dispatch over every sphere that could be in that LOD, and we traverse down the tree, basically. So I think there's a... Oh, where is it? Yeah, we should be doing this. Hey, we've transitioned from there to there. This one went from 3... Ooh. I might not be launching enough threads. What do you reckon that's the problem? How many are here? There's only 8. Or something's culling it too early, something dumb like that. Beep. Not sure what to put there, let's just beep it. Did we hit the beep? Here's some beeps. Here though. That's before we even started. That makes sense. But I was expecting to see some down here between these dispatches. So I'm curious on what sort of... Right, let's go from the CPU side and see what the... So we're gonna put an exit down here, just so it stops. And I kind of want to see what it's trying to launch. So let's just print clusters dim. So I just put 2 numbers in there. We want to do these ones here, right? Because we're doing divide by... There we go, perfect. So I just want to see those numbers and make sure that makes sense. Wait, let's do 3 numbers. The first one is obviously that one. Let's divide by 4 and divide by 2, rounded up. So we're seeing... So the first LOD is going to get 1, 1, 1, right? The next LOD is going to get 2, 1, 1. Why 2? Oh yeah, that makes sense. Sorry, I'm thinking about this in terms of... Right. I was thinking about it as X, Y, Z for a minute for some dumb reason. Let's do it this way. So my brain doesn't like read this information wrong, right? Okay, so there's clustered in and then how it dispatches, right? So the first one you get 1, 1, 1. So there's 32 threads, right? The first one, so there's 32 threads in a wave. Each thread gets a sphere. The first and a cluster is a 2 by 2 by 2 sphere, so they only got 8. So when you're launching these guys, the first one obviously only has 8 spheres, the first LOD 0. So that obviously only needs 1 group to be launched. The second one is a 2 by 2 by 2 of clusters. So that's eight clusters, and each of them have 8 spheres. Just 8 times 8. So yeah, I think we're off by 1. So that's 64, right? So you actually need one of these numbers to be more. So I think we're off by 1. Yeah, I'm doing clusters. Cluster dim. It should be this, right? Cluster dim is 2. Yeah, and then you shift that. I think that's right. Let's see the numbers again. Yeah, I think that makes sense, right? Because that's then 1, 1. Because it's not really clustered in. This is more of like, you want to, it's like how many spheres. So there's like cluster spheres. Something like that, isn't it? Yeah. Yeah, because then that's going to get you. So you got 2 by 2 by 2, right? So 2 cubed, 4 cubed, 8 cubed, and that all makes sense. So I think that is the problem. It seems like it's the that makes sense to me. The reason why it was only limiting us to like the bottom left area, right? Is because we simply wasn't launching enough. So if we simply run this again, okay, the stream could crash if we get but if it does crash, I'll be right back. It's just AMD drivers are just terrible on at the moment. Apparently they're fixing it, but I don't know if they are. Right. So now we're seeing more nodes being created at the end. So this means it's a success, I think. So let's go ahead and undo. No, let's just go ahead and comment things back out, or the print statements. I should have a thing where I make the print statements like conditional based on a compile time variable or something. I don't know. That would probably be better. So now if we run it, we should see the sphere show up inside the texture, which represents, each bit represents a cluster, which is filled with spheres itself, right? So remember, we're painting down. That's the edit code. So here we've got this like operation that we're sort of painting down an ellipsoid, and it happens to be a sphere. And it's at this position in that space of 2, 5, 6 cubed. And we're just, essentially rendering that within a 3D volume of spheres, right? So let's get in. So we should be able to see. So this pass here builds the occupation map, which shows everything. Now we don't expect to see anything. Oh. Wait, I'm not seeing the thing. Damn it. Oh, I know why. I didn't up this number to 7, where the target LOD is where it paints down. So it just stopped too early. Right, so the stream crashes again. I'll be right back. It should be fine. Alright, we're good. Well, there's way too much printing code. What is going on in there? What? Oh wait, this is the printing code for the next shader, the occupation map. So now we know it's actually working. Boom. That's really nice. I like that, that's good. So this means it should be working. Just gotta rerun it in render doc image. Fill buffer. Okay. No, it's not fill buffer. Sorry, it's after clear image. Maybe I was clicking on the wrong one. Alright, here we go. This is it. So if we slide through these slices, we'll see it appear up here, I think. Okay, down there. Ah. Right, but it fully shows. Excellent. So now we're going to move it to the middle and just to test it out. Oh yeah, because it's there, fair play. So 128 in the middle. And then we just say, let's make it 96 big. And let's view the image. So clear color image is the occupation map that we're building. Cleared it, render it. Now we're going to go through the slices and it should appear in the middle. Boom. If I make this number a massive number, so all bits on, because it's a 32-bit integer, would be like 4 billion or whatever, right? So if we just put in some big ass number, oh, wait a minute. There we go. See, for some reason, all of them are not on to say it's surrounded. Wait. Yeah, maybe there's something a bit weird with that. Oh. Like, if you're in the middle, yeah, there's something definitely wrong with this. But that is okay. Fix it. But yeah, as you can tell, around the edges it's meant to be a little bit darker because it's a bit set where each bit in this pixel represents a cluster. And there's some repeated information as well, so we can do some special sampling tricks. So why is it this number? Can I copy the pixel value? Yeah. I wrote it from my compute shader. It's only saying. But anyway, I just want to get this guy. That doesn't look like print it right. 3.3. Yeah, I think. Not sure what's going on there, to be fair. Let's quickly just look at the debug, the code, and see if there's something that just obviously stands out. So we're obviously getting the right shape. It could be the way we're working out the bit. Maybe, or the way we're reaching back and setting the bit. It's one of those two guys, I reckon. Right, let's quickly work this one out. Yeah, so the way this system works, right? Basically, we write into these two bits, right? So, okay, it's a 32-bit integer. So you can build a 4 by 4 by 2, so two of these grids, one behind the other, of bits, right? Where each bit represents a cluster that's filled with spheres. So you can imagine each one of these is a cluster that's got this spheres that should come, anyway, but whatever. There's a way that we can quickly check if all of the cluster's neighbors are completely filled, and therefore we can use a lower level of detail. So yeah, the way this code works is when we write to this one, we only write to these two, and then the rest of them are repeated from the bit sets to the right. Diagonal in this case for these ones. Wait, that could be the problem. And down, these guys. Wait, which one is it again? Yeah. Maybe I didn't solve diagonal or something like that. That's probably it. This is why it's great to describe stuff. Right, so this one... Yeah, so when we write this one, it actually writes back to the one to the left. So imagine, this is the one to the left, right? And it writes it to wait, okay. Imagine this one's the one to the left, and it writes it to this space here, right? So it's repeated over there somewhere, or whatever. And it writes this one here, it repeats it over in that one here, right? So this whole area is repeated over there in that area there, right? So it means when we sample it in the shader in the future and check from it, we land our positions within here. So we only look at the clusters in this space here. And then because of that, we guarantee that there's a whole border that we can look around. So say if we go, hey, is this cluster fully surrounded by clusters? You just check all these bits around here. And obviously in the near and the far as well. And then voila. So you can do that with two samples, which is pretty neat. So yeah, the thing that was I kind of said was this one goes diagonal, but I have only code for that. So if these ones reach back, so if you only write for these guys, and you've got something that's these ones should be written. Yeah, this should be written to the left as this. It should be written to the diagonal as this, and it should be written as the above in this. That's right, isn't it? Yes. That's what we was missing. So here, the reason why we're saying if it's not 0 is because there's actually a border. Wait, where is it? No, because that's the 0 bit that you're getting. Yeah. Duh. So you now want to do another one, right? It's kind of obvious. Bay. And you want to go back by 1 in both of them. Now you got to do the whole. Okay. So the reason why I said bit plus 2 here is because if you have your x coordinate, you're painting down. You're painting down something here. Bit plus 2 lands you there in the previous one to the left, right? Bit plus 8. So 8 is 2 rows, right? That's 2 rows, and it lands you there. So from here, you add 8 and it gets you there. Yeah. If you're painting in this area, that's what happens. Now to get diagonal over here, what is that? So it's probably 8 plus 4, right? So it's 12 in it. So if you do 8, that'll land you there, and you need another 4. Or another 2, wait. Another 2, 10 then. That'll get you here. So to get from here to here is plus 10, right? To get from here to here is also plus 10. Plus 10, right? So that's cool. Excellent. So that should mean it will work. But again, if it crashes the machine, you know where I'll be. I'll be right back. All right, it still runs. I'd like to see. And if we look, so we'll see this value. It should be 4 billion, 200 whatever billion. But it's not. So hopefully, if we run it again, we see that fix. So view the texture, go through the slices, find the thing we've written out to, right click. Any change? No. Maybe there's some change there. See, there's only one slice. I'm only writing on one slice. There's something else I need to write back on. Because I've got one. There's only 16 bits, right? There's another layer behind. Do I need to do a near and far as well? I've just missed. But I thought that came. Oh, did we not reach back on the near? Right, yeah. So we only paint in this area, even on this slice, even there's a slice behind it, because the one on the sort of the slice of this behind it, when you write to that, like that one's never gonna get written to. Sorry, what's the way of saying it? This area on the slice of 4x4 behind, right, within the same 32-bit bit set, is going to get written to by the next bit set behind this one when it reaches back and writes its results. But I haven't written that code yet. So that's probably the issue as well. So I forgot about the z-axis. So there's some more writes there, which is a bit of a shame. But hopefully it's not too bad. The performance already was... Wait, why is that 4 milliseconds? Is there a... Yeah, we can probably speed this one up. But it's kind of like bouncing between. Maybe that because it's fighting with OBS or something. Because OBS runs at 30 FPS, I think. It shouldn't be this noisy. You know, as a true programmer, I like to blame other people's software first, But anyway. I wonder why this is noisy. This result. Yeah, so I think we should we have to reach back along the Z. But then we're going to have to reach back along the Z. So we're going to have to do, there's a lot of little rets we have to do. We have to do all the, yeah. So we need to do a Z1 like this, right? And that would mean it's just plus 16, right? Because it's just one slice. You're writing back to the previous bit set, but in the next slice, right? So you're moving your bit 16. Okay, that one's pretty easy. So the next, so have we got to do all the other configurations? I think we have to. We have to go, we have to say, well, if you have Y and Z, for instance, right? So that'd be 1, 0. And then let's just get them all written out. Then you need X and Z. Then you need all of them. Is that right? X, Z, Y, previous Y, Z. Yeah. It's in 3D though, so is there even more? Because you've got from your bit, so the way this works is it just goes over every single cluster and sees if it's right. Oh no, sorry, you get the cluster, then it goes, for this cluster, it goes over all the pixel, all the bits where it's going to be, isn't it? Hmm. You'll be alright. But yeah, so you've got yeah, you're only doing one side. But yeah, so it is adding all of these lot. So you're doing back, diagonal, up, right? Something like that. Whatever the orientation is, I forget. And then you're doing it in 3 dimensions. So you've got the kind of one going this way. You haven't got one going that way. And you've got one going diagonal between. So you've got diagonal, you've got near left. You've got up near. And then you've got up and left near. So that is should be 7, right? Yeah. Excellent. So it's got to get full on diagonal one in there. Rightio. So let's just get these bit sequences working out all right. I'm not sure if there's a better algorithm to to write this out in, because you could go over all of the bits. Like maybe we can just fill this occupation map out while we're building this perhaps. Well, yeah, I don't know. No, maybe. Um, Maybe we could build the occupation map. There's probably a smarter way you can write this. Like, if this extends, like, because if this is painted on a lower LOD and does multiple of these, maybe it would fill in whole bit sets basically with the same value. So you can do it in a single write. Yeah, something like that you can do, but I can't be bothered right now. Let's just see. Let's just get it up and running. Make it better later. Okay, so this one goes up and near. So we're trying to go. So you're going up and near. So it's basically plus 16. But you end up down here, right? So it's plus 16 plus 8, right? So it's 24. Then plus 16 plus 2, right? Then all of them in is plus 16 plus 8 plus 2. Should be it. Yeah. So that should be all the bits, all the bells and whistles. Yeah, this goes. Started trying to learn Unreal Engine, quickly realized I have no talent for animation, 3D modeling, FX, sounds, etc. lol. My programming is like kindergarten level 2. No, good things don't come easy. Yeah, you kind of the world of game development is complicated. You know, um, like basically you can do all of the things eventually. Um, you've just got to obviously pick it up and learn it. And obviously you won't be able to become. You'll be able to become a master at some of them, but not all of them. But the idea is you want to like pick something that you enjoy and just knuckle down and get really good at it. But also, I'm sure you'd be interested in multiple things. Also learn those as well, but not to the same degree as your primary one you want to learn. Um, so um, because like it's not that great being someone who just knows one thing. Although if you were to get a job, it's obviously best if you really know that thing very well. But you really do benefit from knowing how different parts of a game gets put together and all of that stuff, right? Um, 'Cause it really helps. It really helps you do better in that thing you're trying to master, but also work with other people on a team as well. Um, so yeah, I highly recommend you just pick a primary thing and a secondary thing, and just spend more time doing the primary thing, do the secondary thing a little bit less. Well, probably much less, but still do it. And maybe do a third thing as well. No problem with that. Yeah, learning the needs of something else can be a big benefit. It's very, very sound advice. It makes me a bit sad that the time will be taken away as I learn. Nah, don't worry about it. Like, like the idea of making stuff is to have fun, and if you've had fun while doing it, it's not really a waste. And then you've taken something away and you've learned from it. Um, obviously, it's really great to sort of release stuff and people use it and everything. But the primary thing is, have fun, learn stuff, um, basically. Um, but yeah, it's definitely best to start on more of a smaller thing though, because the problems are simpler and the interactions between those different disciplines are simpler as well. Um, so you'll be able to learn stuff at a simpler level. Um, so obviously make a simple game like chess or Pong, Tetris with a little bit of a spin. Give that a go. Yeah, exactly. And even just do it in doing your own sort of engine or whatever. Or just use like Raylib or whatever, SDL2 or something like that, and probably Raylib actually if you're just starting out. And build something of your own. And build these things and keep them. And make sure you can um, maybe put them up on YouTube or something like that. And you might think it's not really great, no one's going to watch these, but um, when you want to apply for maybe like an entry level job, if you just show and you've like made something, um, it goes a long way that you're able to sort of show that you've made something from scratch, and even if you put the source code or something as well, you can do that too. Yeah, exactly. And then just build the next thing. It's probably not going to be amazing, but it'll be better than the last thing. Just keep going. And then just increasing complexity there. Um, oh yeah, we made a thing. So I'm hoping we've set all the bits, all the bells and whistles, the bits and bobs in the bit set. We've got all the directions now. I forgot we was working in 3D, right? My 2D brain was like 2D, right? Okay, so here's our boy. Oh, the number is still the damn same. What's going on? I don't believe this number. It's lying to me. How can? I swear this number's lying to me. We've literally changed code. Eh. I think it's lying. It must be lying. I will literally just... The code is fine, right? Um... We're setting all the bits we need, right? Going back near... It's even slower. It's like twice as slow as it was. It's definitely doing the work. I'm just confused on why why these bits, but it's great because we have the number, and the number tells us exactly what bits. Yeah, we just got to split this into. There's my binary. Copy that, and it'll tell us what ones are missing. I don't know what's the endianness of this, but So there's one slice. And there's the other slice. So clearly we write in these guys, but these ones aren't being written to. Well, I don't know what's going on. Yeah, I'm not sure what the endiness of this data is at all. But we are seeing, the fact that we're seeing 1111 means there is some reach back happening. I have a feel that this is the area that's getting written to by the main right. But, yeah. Yeah, but the number didn't even change, which is really weird. Let's comment out all the right back and see if the number changes. There's the number, right. I want to compile that. Hey there, RT Brick, Burkless. Hey, welcome. How you doing? Yeah, things are good, man. Just well, we're spending like a long time designing how we want to make this more scalable. We just got two instances of spheres that we're sort of ray tracing against. We want to try and make them like much smaller and have tons more of them and scale. So we've built this like big LOD cluster system, and we're just trying to get it up and running without using too much memory and building these clusters on the these clusters of spheres on the GPU. But we're not rendering anything yet. We're just trying to get it actually in memory first before we ray traced against that. Well, before we're actually just going to reuse the current ray tracers, but just bring it. We'll basically go through the cluster tree, and we'll sort of like we're gonna essentially just we're gonna take these spheres, move them into like view space, and place them into the screen space bins, and ray trace against those. But yeah, we're just executing on some complicated plan, and it's going somewhere. Going somewhere. I was streaming, but the stream quality died. No. Then I'm here, what coding? Awesome. Quite nice, interesting stuff. Thank you, thank you. So number not good. This number needs to be filled with all bits on because it should be surrounded by the clusters, right? So we can simplify it. Right, so let's go through the slices. Right click here. The number has changed. 3999. Damn it, I'll write it out again. 3342 387. So yeah, okay, so the 99 was showing those right back. 87. So this is like the first row which had 111 there. If I put those there, probably 99, yeah? Excellent. So this shows there is right back happening along the x-axis just fine. But it wasn't happening along the others for some reason. Oh, on that specific, well, maybe the data could be different on the different, we'll see. No, this is a rendered doc. Yeah, this is rendered doc, so you can view GPU memory and all that stuff. Yeah, this is NeoVim, and then we yeah, wobbly windows KDE. But yeah, this is my project here, basically, this little renderer. We have got a UI system in here, but I've just not got anything up right now. I actually need to take a pass over it and make it so we can. I actually just need to build some UI in it, to be fair. But we spent some time making a UI. Not got anything up. Where? So let's re-enable this code. So in the dispatch we find writes out. Okay, so all of them the same? Yeah, they're all the same. Okay, so this number, I assume it's only writing back the x-axis. So if we literally disable this one, we should see that that number is reverted back to that 87 number at the end. And if that is true, then it means that the rest are not even writing back for some reason, and that might be one of the coordinate. The coordinate variable could be wrong. I don't know why it is. It's very weird. No, it's still showing 99. 4739. That's the number. Interesting. Where's the one then? Let's rerun it again. I'm still confused. $399 still. Gonna be Z. It might be a combination of them for some reason. Alright, let's go back to this right again. Slide through here. Still got that 399 value. It's just a bitwise or. Right, I do remember actually we have got a bit of a problem with some of the allocations. No, the allocations, some of the constants, one of the constants is a little bit wrong. Right, let's just carry on with this and then we'll fix it in just a second. 399. Okay, it's still there. I have a feeling it could be that one then. But we'll see, we'll keep going. Okay, still 399. Right, let's cut to the chase to see if it's this one that's actually given us something. You're right, 391. Interesting. So these two are both writing. Let's comment this one out. See, I wonder then if we enable that one. Wait, disable that one. Did I miss something? It could be that only the Z-axis ones are actually writing back for some reason. I'm a bit confused. Still 399 here. 4, 2, 3. It's the same number. So these two are the ones that are only writing back. So why don't we single out a single node? So we'll go, hey, if this node is at, and we'll say, we'll say, hey, if a cluster coordinate, I want to say all of probably equal e32 times 3 with, I don't know, 128, dead bang in the middle. Then we want to do this printing here, yeah. And that should help us. No, I'm not seeing any printing code. 20. That's the middle of the this is divided by 2 and it only lands as high as 40 odd. But where's our sort of, it's going in the middle. So we should be seeing some clusters which are, let's do less than. Let's do greater than rather. Right, so it's anything greater than that. Let's do greater than. Oh. No? Okay, so I just realized 64 would be in the middle. Because the volume is 256 cubed spheres, but a cluster is 2 by 2 by 2 spheres. So a volume of a cluster in the volume of a, sorry, the dimensions of a volume in clusters is 128 cubed. 64 would be in the middle. Right, we found our boy. Here we go. So in here, we can put some information to help us debug what's going on. So why? So we want to know. So what do we want to know? So I guess could we look at the bit? Could it be to do with the Z? We said was only writing in the top left. The top left. We wasn't writing. Whereas we was only writing in these 4 pixels here because the rest of them including on the slice behind, because this is 4x4, right? So in the 32-bit integer, you're going to get 2 of these. But the ones behind these are going to get written back by these 7 right backs, right? So you got 1, 2, 3, then 4, 5, 6, 7 behind, right? Which are areas which will get written to here. So the reason, so it's something to do with the addressing. The bit here should only be, so there should be no z coord, the bit coord dot z, I think. Just think about that. So this would mean, so your cluster coordinate, right, your coord is going to be dot xy dot z. That should be it. Oh. Oh, right, I've now got a sort of a function that constructs from those two. So I think what we've got to do is just do that, and we'll let the compiler sort that one out. So what we're trying to say here is the z coordinate. Yeah, I got to make sure this comment all makes sense. The end. So we're saying that the z coordinate we just use the proper cluster z coordinate since the sort of the reach the sort of repeated data lands, since we just write to the first 2x2 of each bit set, before the repeated reach back, something like that. So that should be it. Let's double check it, and then we'll sort out the what's going on here. Alright, it's good. So let's put back all of this. Oh. Right, so if it crashes, I'll be right back. You know the drill. Should be fine though. Right, we're good. So if we see this, that's sketchy now. We actually wrote out of bounds there. That should have crashed, but I think buffers crash and textures have protection for some reason. AMD hardware, I don't know. But yeah, that textures actually needs double on the Z. So we need x, z, need double on the z, just plus 1 there. Okay. I'm lucky we left that print statement in, actually. Rightio. So it means that in this view now, the shape should feel bigger when we go through the slices, and we should show the proper values now. Right, let's give that a spin. Hopefully that works. Right, here we go. I've only got 63 in there. Bit. It's not what we're looking for. What is 63 in? It's all the bits on, isn't it? So that means you got one row. That gives you one row and a bit. So we're definitely seeing some form of reach back. Seeing one row and a bit. I wonder if the Z is messed up now. No, I think that's alright. No, I think that's wrong. What was the change we've just made? I think that's wrong. It is meant to reach back. You got 2 in a slice. Right, I think I know. Right. So I'm not sure we needed this to be doubled, but let's just double check. So, if you write back to the slice behind this one, it's behind this whole slice of 4x4. If we write back to the one behind this one, this has to reach back. Right. Hmm. There's no reaching back along the z-axis and writing back, because it's tightly packed together and we do 2 samples on it. Yeah, so that was the trick we did. Okay, so let's reread this comment I wrote in the past. There's a 4x4x2 bit set, and is address space in 2x2x2. We use the final 2 rows and 2 columns as a repeat of the first 2 columns and 2 rows, or 2 rows and columns. So these are the first 2 row and column. Of the first 2x2x2. So something's definitely fishy. This allows us to get away with loading 2-bit sets when we check for our neighbors, right? In a feature shader. Something's definitely weird. You've got this 2x2. And you could have written a bit in any of these 2x2s or the one behind it. So if we address it as a 2x2x2 instead of a 4x4x2, like this is where the first set of clusters will go, then over here in the next one, right? That's fine. And then, but when we work out, this will just have an offset into these guys. Then we work this out. It'll be either this one or 16 ahead, which would be behind it, which is what this is. Or one down, or one behind it, which is what this code is here, plus the x, which will either get you 1 or 0 basically, right? Cool. So you don't have to reach back along the z. Still confused on why we're not reaching a lot of the area then. This is great for the performance. You don't have to do the reach back. LOD. No. So this one, you go one back along the x to the left-hand side, and you've got this bit here you've written. You're writing it here in that bit set to the left. So simply, wait, sorry, wrong one, here. So simply +2. Right, okay, that's fine. So even if you're the slice behind, even if you've written the slice behind, that still makes sense. See, I think some of them are, when they get a little bit more, like, I think these two are probably fine because it's just +8, where it takes it down a layer. Oh, takes down 2 layers. Yeah, that's fine. So it's written here. It'll take it down to there when it goes up. But along a Z, there's no reach back along the Z. Make any sense? Because so we was just missing this one. Is that true though? Yeah, because only these guys are repeated and not along the Z. So if you write here and you want to get to, you write into this position, diagonal that way, right? It is simply plus 8, right? 2 rows, gets there, plus 2, so it's 10. It all seems fine. But when we look at the value in the shader, it's off. So I have to redo that. So I don't need to do those Z ones, which is good. It's less, like we run that now. It was at 0.4 ms, this is at 0.2 ms now, so it made it a lot quicker. I reckon there might be a way to optimize it further, but it's good enough for now. So the bit that concerns me is when I look at this value. It's not the bits that we're looking for. Hey Joe Mega, how's it going? How you doing? How you been? So why isn't it the bits that we're looking for? I think it literally just shows that there's a 3343 42399. That's what I meant. So the first row is on, so there's a repeat happening. The second one, we should be seeing all these bits on. Like all of them. Basically, it's very weird. We're seeing the slice behind. We're right into these two. Right, so let's now expand what we're looking for. Let's look at cluster. So I'm not sure what we're trying to find, but let's do a 2x2 region, I guess. Let's do 5. They're going to be in the same bit set, right? So it'd be 65. Man, kind of sick. Oh no, did you catch the have you caught like the flu that's going around? 65. Okay, 65, 65, 65. Let's just do the ones that sort of next to each other along the X and Y and just analyze those. Those should all be in the same. Okay, they're not in the same one because there's an off by 1. That makes sense. Right, so let's budge them all up by 1. There's an off by 1 here because the way we got an empty border. I don't think that's messing us up. Right, because they're all in bit 33. So now the next piece of information that we want to see is probably the bit they're trying to set in 33. Yeah, so we probably want to see the bit they're trying to set. So we do this. So we're seeing 1, 2. So they're done in and then we're seeing the next row 1 and 2. Seems legit to me. What about the next? Let's do another one of these, and let's up it. Let's go along the Z this time. We should be seeing the same information, but along the next slice. That's perfect, isn't it? Yeah, so bit 1 and bit 2, right? Along the X. Then we're seeing bit 1 and 2 along the Y. Then we're seeing 1 and 2 along the X, along the back slice, Z slice, right? Is that right? And then the Y slice. Is that right? Because you got those bits there. Yeah. Yeah, that's right. Looking good. So you should be oring those into the same thing. Huh? What? Let's look for that instruction in the. Oh no, crap! What am I talking about? I want to cat it. Oh no, I want to spivvy this it. Man, I'm all over the place. Spivvy this. Oh, here we go. Looking for atomic. We should be seeing a bunch of atomic ore. Yeah, because I've only got a few. I've got 4 in this shader, and I got like another one. One above. So 4 in this shader. Yeah, so they're definitely there. Yeah, and one in a future shader or something like that, right? Yeah, this is in the future shader. Yeah, 2 more afterwards. So there's like 1 up there, then there's 4, and then 2 more. Okay, so definitely in there. It's not a compiler bug. Also working a bit more on my input system. Finally support multiple keyboards and mice as separate devices. Currently working on the controller. Gonna be stuff like X input at the moment. But that does mean I can't access paddles and trigger motors on the Xbox controllers. And no, I think it's a sinus acting up. Oh, okay, gotcha. Yeah, Yeah, the Windows situation is pretty naff with input controllers. On it's a bit nicer on Linux because you get you've got you got udev basically, and it's a bit nicer. But yeah, it's just a weird situation having to deal with the controllers. And parsing some of the data is just weird. Right, so the bit that we're writing in seems legit. And when we sort of add 2 or add 8. Oh, wrong one. Hmm. Am I misreading this? That's 16, obviously, right? So, did I add the wrong number? Because we need to land, these are the first 4. I need to add 15. I think it's the problem is where I'm adding these numbers. Right. I think this might be the issue. No, I need to be shifting, innit? Not adding. Yeah, so I was thinking in shifts, but I was using the add operator. That's probably what it was. So I need to shift. Yeah, so shift 8, right? So 1 shift left 8 will get you too far. No, shift 4, won't it? No, I was just completely wrong. So this needs to be shift 4. This needs to be shift 4. Oh, so which way are we shifting? Yeah, it is left, isn't it? Shift 2. And then this needs to be... Right, let's get back up this graph. So to get from here to here, that's just shift 2 to the left. Or whatever, the way you look at it. I think you might be done. Yeah, I'm not sure. Anyway, whatever orientation we're looking at. So you shift 2 to get from here. So 4 gets you a row, then it's 8. It is 8. So anyway, so shift an 8. I think I was adding instead of shifting. That was it. And then it's 10. Right, so that could be the fix then. So this is all correct. Just get rid of this print. All right, let's look at that data. If it wasn't for the special driver for Xbox controllers, it's just hid reports. Yeah, I like how the PS5 controller does it. Awesome. But it's because legacy stuff, so it makes the triggers be a single axis. Yeah. Yes, that is bananas. They support legacy support so well that they completely bugger up a game controller. Ugh. Alright, I think this should be it. Ah, yes, that number is good. We did it. Man, I can't believe that. I did addition instead of shifting, and I completely underlooked the problem. Right, it's all good. So now we just got to downsample this texture. It's different MIP levels should be. Awesome. Yeah, I'm sure you'll be making a game soon, Joe Mega. But yeah, it's all cool building. Like, yeah, it's very easy to speak to Joe Mega, and he'll come and talk to you about his new thing he's building, and you just get interested in it, and you just want to start building your own one, you know. Yeah, I'm doing ray tracing, so I'm doing compute shader ray tracing. So it's basically like so we're not using the ray tracing hardware. We're using the like the ray tracing APIs in Vulkan. We're using compute shaders. So we're just doing it in software, if you will. Yeah. So it's always of use to like build a ray tracer from scratch. Those sorts of tutorials. It's just something like that. Okay. So each bit in this bit set represents a cluster which is filled with spheres, and because this is in the middle of this sort of sphere we've painted down into this volume of spheres, these bits should all be on, right? Except for the ones near the edge. So you should be able to see that if you do something like this. Oh, damn it. So as you see, the ones near the edge, they get a bit darker. That's because these guys are not full clusters. They're partly full. Right. Since it's easy to forget, since I get it's easy to forget as I haven't been here a bit, it's fine. But here and here makes kind of hurt. Sorry, Jim, I guess it's not obvious, is it? Well, it's not intentional. Apologies. But anyways, we're gonna land on. That's all right. Awesome. Okay. So now we're gonna work on a downsampler. So we read this texture in the future, and we can check. We're given a cluster of 2x2 spheres. We can easily check the surrounding clusters to see if it's completely surrounded, and if so, we'll downgrade a 2x2 set of spheres just to a single sphere in the lower level of detail, right? But this is great for the highest level of detail. So to make the same trick work for the low levels of details, we need to essentially do a full MIP chain of this texture. But I think, yeah, so we just got to work that one out. So we need to work on the MIPs, on the views. So this one is a occupation map. They've done MIPS before. Yeah, MIPS base ID, that's how we're gonna roll. They call it buffer ID, it's texture, man. Right. Alright, so now we're back here. We want to make a new one of these guys. We're going to call it the MIP texture MIPS base ID. So we need to create some texture views, and we're going to make them in sequentially allocate their IDs. So we can just use a base ID. So we do it here. So we need this one here. And we're going to do a similar sort of thing. So how many MIPS do we need? So I think it's LOD take 1. Because it's half the resolution, like clusters of 2x2x2 of spheres. So in a 256 volume, there's 128 cubed clusters. So yeah, we want to go over all those, and this would be view. So you got your base MIP level, excellent. Right, so this is how many MIP levels we got. So this is occupation map MIPS count. Occupation map MIPS count. So we say like clusters are 128 cubed. So one less LOD. Those, something like that, right? And also, thinking about it, do you go the whole way? Wait, it might be 2 down. Because one bit set covers a 2x2x2 area. Anyway. So at LOD 0, your bit set, it covers that full 1, doesn't it? But you need a... No. Wait, does it? Yes, you're going down from 65 basically, and you're halving it every time. So unfortunately it can't be 64 because we've got a 1 bit padding around the edge. That is 6. Yeah, I think it is take 2. And 1 less for less for 2 by 2 by 2 for each bit, so something like that. Something like that. Okay, so that should be alright. Just got to initialize the base MIP. And there we go. So now we've got to plug in our new shader. It's the custom downsampler. I was hoping to get this one working today as well. This is going to downsample it. Should be easy to do. So we just got to pass in these to occupation map. Occupation map. Right. So we're gonna run this like as many times as we have MIPS, something like that, or one less. I should really chuck that in the well, that's a lot. It's a big word. I think I'll just do for now. Okay, I didn't change the type. Alright. So we can use this. Occupation map. Here's where we dispatch it. Excellent. So we just need to do a for loop over this basically. It might need to be a reverse one, I'm not sure. We'll see. So maybe let's use word index and we can just do something. So here's our constants. Really the way this should work is we should zero initialize them all the time, just in case we forget to initialize something. So we need to initialize destination and source. So in each, so we can start them off and then we simply just increment their number maybe. And then you have to synchronize every time. Oh. Wait, how did I do this before? Have I got a downsample somewhere? I could have swore I did an occlusion one. Ah, I just synchronized on the whole thing. Got it. Easy. So you synchronize on the base. Cluster occupation MIPS base ID. Fantastic. And we'll start this one off on +1. Awesome. Yeah. Hey, Closure Honey. Welcome. How you doing? As you can tell, the bot here is to remind you, is to keep you grounded, you know. And then we need to do a dispatch. Non-indirect. It's a regular one. But I need to work out the dimensions. So we're launching over... maybe I've put an if statement in here. Each wave is a bit set within a destination texture. Each thread is a bit within the destination texture. Oh, we might be able to do it perfect. Ooh, that might be interesting. Huh. So, how do we work out how many bits we got? So you have 65. Oh, this is where it's a bit of a bugger. Must be a divide round up, isn't it? Yeah, I think so. So we'll start off on the full size, which is like the full res, which unfortunately is this number here. This is the resolution. Oh, I'll call it dims, right? Dim. So basically we want to do a divide rounded up with 2 every time at the end. So this would mean, so each thread, each wave is a bit set. So how many waves do we need to launch, basically? In the destination texture. Destination is 1 lower. Source texture is 1 higher. Because it's downsampling, right? So... oh, I need to get the size off thing right. Apparently Microsoft pushed a broken update on Windows. They recommend you fix by pasting command into PowerShell. Ooh. Is that for every user? Yeah, but that's only when you see. Not if you don't see. Oh. They finally say I use Windows, by the way. Oh no. And I still don't understand that some people voluntarily want to deal with C's. We got generics at home. Yeah, that's cool. The problem with templates is people start using templates to the extreme. Basically, and it just slows down compile times. I feel like uh I feel like if you had a better macro system, right, which still made templates feel ugly, right, essentially, you have templates but with macros, but made it so that it was better, a better macro system than we have. I feel like it would still scare people enough away from using templates, but then still be there if you really needed them, you know? Because, yeah, when people have templates, they just template everything. Just look at Rust standard library. Just look at any C++ code base, and you'll see that, right? Well, you can go crazy with templates, but have you seen what people have done with macros? Yeah, people do crazy stuff with macros too, but they're less likely to go full crazy with it because they realize how crazy it is earlier. Right. Surely. Um, yeah, I guess if people just keep with it, there's no helping those people, is there? Um, right, so how are we going to launch across these? Each wave is a bit set. Like we know we have 65 or whatever bit sets, right? That's just dim. Um, it might be just this then. Oh, no, no, no. Close though. And then 2 for the last one. Because it's 4 by 4 by 2, right? So if you've got 65 on the first one, it's I don't know how many times it goes in, so it'd be 16. Plus another one's 17. Um, no, it's a little bit off in it. Wait, it's in the destination texture. So the divide happens before. So your resolution will be 33. Something like that. It'll be 33 bits. So it's just dim. Wait. Right. I think that's the answer. So this should be able to downsample all those shaders. So all those basically downsample this texture into different map levels, right? Just got to check the. Just got to, I think, check the code one more time because it could just blow up the computer. Surely, well, that's sounding confident. Well, yeah, well, they're harder to work with, I guess. So, pretty sure about that. Flashbacks to STV stretch above code. Yeah, that's pretty much just macro. Like every sort of operation is macro, like a big old one in it. It'd be better if it was CodeGen's functions. Mhm. Yeah, this was like yeah, like he's got another library which basically replaces this one. But this was like a long time ago. Um, this is a pretty old one. Where I think this basically didn't it used it made a header, didn't it? Yeah, it made a header, something like that. Yeah, there's take ones in here. So there's like a little header with the count before the buffer. Um, yeah, it's typical Sean Barrett code where it's just pretty dense. But he's made a one which that replaced it. This one, STVDS, where it's got arrays and hash tables and stuff like that, where it works on a similar sort of way, where it has a little header that sits before every array basically and does it that way. Yeah. Right, so the source coordinate subtract 1 for the empty border, right? If it's set, if we didn't underflow, then we load from the source texture, right? We check the bits that we want to look for, and if they're all there, this thing is set. This bit is set. We're finding the thread index of where to set our bit. Yes, that's checking a 2 by 2 by 2. And if they're all set in that 2 by 2 by 2, then right. Yeah. We poke. Yeah. We move the bit into the right place based on the thread index, and then we use the wave active bit OR to essentially combine every thread that runs in lockstep into a single bit set. Then over the first thread, we store that out into the texture. That makes sense. Just got to make sure this actually maps to the right instruction. So I want to... What is that? It's like a group. Op group bitwise. Let's just double check that's actually in there. How much preprocessor? Yes, all the preprocessor. But to be fair, preprocessor isn't that much of a bad idea, right? I'm sure there's, like, basically in Rust, they fix a lot of their problems with a preprocessor, right? They fix it with procedural macros, right? So it does exist there, right? And if you don't have those things, the language is actually quite hard to use because you do repeat lots of stuff, right? So what are we writing out then? Non-uniform bitwise OR, so it does show up. So if I were to sort of comment that line of code out, does it disappear? Maybe let's just replace it with like a 0. Just see something like that. Right, so it disappears. So I write out the right instruction. That's good because I don't think I've used that one before. So it's good to check that. Right, so the stream goes down. I'll be right back. You know, AMD drivers and all. Right. Okay, so we've got a CPU crash instead. Mid-range is out of bounds. Yeah. I don't know, it's quite small code to be honest. Like, it's not a lot of code that just calls realloc, right? Because at the end of the day, it kind of implements like a growable array. So it's more than that, and it's pretty dense, right? It's like 80 lines of code. So it's not just calling realloc, right? Like, okay, so what are we looking for? We're looking for when we initialize the occupation map MIPS. So it's when we do this texture view. How many? Okay, we haven't actually put the MIPS count in here. I forget which one it is, which is the problem with functions. But I think it's about. Yeah, here it is. Okay, it's the first one. That one there. Boom. So that should initialize the texture. Right, if the stream crashes, I'll be right back. Let's go. Right, we're still running. Game still runs. We're doing a downsample, are we? Yes. Do downsample this many times. Excellent. So the first one's the most expensive, as you would expect. So let's take a look into the texture now, right? So I'm going to run it in RenderDoc. And what we should see. Oops. Right, so this one's now got MIPS. So we're going to slide to the slice. Right, so obviously the first one still looks fine, right? Let's go to the next MIP. Now I'm going to go for the slices. We see absolutely nothing. This is a shame. Oh. So clearly the AND code is wrong. Alright, so just got to think how this can actually work. So let's make sure we're launching this thing just fine. Occupation. Right, so the destination texture is obviously 1 plus that. I guess we can check this one. Oh, my mistake. I did not go past in the. Okay, this is good. This is good. No. Right, so there's the first MIP. That's a bit weird. This is also a bit weird. I think the. Okay, so at least we're getting something. Like that should probably be. It's definitely off-centered, right? But it's probably the right shape. Let's figure out what the hell's going on. So it's right into the right destination, but the sort of the source that it's reading from. It's dispatch indexed correct. So you've got. Where's our little bit set? Here we go. You've got your bit set, and what you're saying is. So you're getting your sort of your bit. This is representing a bit. Hmm. Right, Catch that Jamaica, good to see you. Have a good one. Hope you feel better soon, my friend. Thank you for popping by. So the thing is, we've got repeated data. This is why we need a custom downsample shader, right? So this is the uniquely written data. and all of these guys are all repeated data from the other bit sets, the neighboring bit sets. So when we downsample, just got to be careful. So there's a border pixel. There's a bit border where that's always 0. We don't write to it ever. So that's another thing we need to check actually, is filling it. Filling up the whole area and just see how this responds. So if we take this dispatch index, which represents a bit within the destination texture. But in the source texture, what would it represent? Source texture is 2 times this. I forgot how it was now. So imagine if we're trying to say, hey, I want to write into this one here. Remember, there's that border on the initial bit set. It's going to say look. It'll say take away 1 and look into along all axes and look in the source texture at this coordinate. So this was 1 by 1 by 1. Now this is 0 by 0 by 0, right? Because we're not the max value. That should be any. Oh, if all are not equal. Okay, sorry. So we grab that bit set, then we check for these bits. Let's just double check that. So it's 0, 0, 6, 6, 0, 0, 0. So there's 4. There's another 4. There's another 4. Okay. Yep, that's good. So this is saying these guys here, right? Because the first 4 are off. The next 4 have half them on. So it's talking about these guys here. So what was that looking at? So it's saying look in that bit set. Right, that's the way it's saying it. Looking at the 0, 0 bit set, then look at these guys here and check if they're all on. And if they are, we can successfully downsample this guy here. Now, if you're looking at doing this one here, is 2 by 2 by 2, you're saying look at the 1 by 1 by 1 bit set and check this area here. That feels right. So it is kind of working, right? So here's the MIP1. It does show up, but it's showing up offset here. It should really be here. So we can say this is working. But could it really be the destination? Or could it be the sample location? That's off. Hmm. Or could it be the sample location? So you're going to do this bit here, which is technically in the repeat area of these guys. You're saying, yeah, I think it's not right, the sampling. The 111. Right. So this will look at 222 or something like that. The bit set, and then checking those bits there. If that bit is on. Yeah, we're going too fast, and we're not accounting for the repeat. That's the problem. Um, so we need to do something special where we treat it as if it's like a. Well, I think we just do a divide by 2. And then it will truncate, and then they'll land in the same thing, basically. So if we literally just do a divide by 2, it might be enough. We'll have to divide and then a subtract. Just got to think about that. So going for this bit in the destination texture, that's 111, for instance. You need to go to bit set 0, divide by 1. Sorry, divide by 2 rather. So that'll land you in 0. And then you check if those are on. If you're not getting this, you're getting the same bits together. That's the problem, isn't it? Like these. Oh, what do we need to do? So what's different from a regular downsample? So from a regular downsample, you'll take like a 2 by 2 set of pixels, but we're gonna say these are bits, right? You say 2 by 2, and these will make a pixel or a bit. Why can't we do that? The reason is because can we do that? Can we do that? Because yeah, this information needs to be repeat information from the one that is over there. So this 2 by 2 by 2. Oh, there's that damn border as well. That's really annoying. But this 2 by 2 by 2 needs to be a repeat. Also, it needs to be unique data and then be repeated over there, or whatever. In these guys, right? So how might we achieve this? So when you're trying to fill in for this pixel or this bit here, you need to be looking at the same at the next place. So it might be like the divide operation, but it said you do an add. Maybe. Right, it might be something like this because of the border. So there's an initial border that we need to keep around the edge. So let's say you're filling in this bit here. This is going to come from the first bit set. And it's going to come from this area here as we... Is that right? Yeah, it comes from the first area here. So if you did an add 1, so you got like a 1 by 1 by 1. So that'd be 2. Divide by 2 is 0. And then you'll land... Yes, that all works the same. So let's carry on and see what we get. So if we go to the right by 1, that's like 2 by 1 by 1, like that. This should be a repeated information, right? So you've added 1, so now you're 3. Then 3 divided by 2 gets you 1. That's right. Yeah, so it would get you, then you check the middle of that. Because this is repeated information, and you're getting 1 to the right in the higher resolution. So you're grabbing it from here in the middle, right? Checking those. Yes, that makes sense. So this one, okay, is 3 already on the x. So you'll be adding 1, dividing by, so it'd be 4 divided by 2, which would be... Oh no, where is it? I think you need to do the add afterwards. So, right, so start again. So 1 by 1 by 1, divide by 2, and then plus 1. See, it's that plus 1 that's not good in that case. But in this case here, it'll be 2 by 1 by 1, divide by 2, 1 plus 1, which would be 2. So you might, right, then that'd be 2. Then here, it will be 3, divide by 2, which would be 1, plus 1, which would be 2. So I think the plus 1 is just not needed. And it just works. Because basically you're getting these, which are this is repeat information from the next bit set, to fall into the same 2 by 2 in the one up. I think that is correct. That sounds right. So let's just double check that one more time. So 1 by 1 by 1, right? You're just going to divide it by 2. That'll land you at 0. The 0 bit set, which means you'll get this area in that 0 bit set, right? Then this is 2 on the x, 2 along the x, right? Which means divide by 2 get you 1. So that gets you the 1 bit set. This is 3 divided by 2, which would get you 1 as well because it's rounded down. That get you into the 1 bit set where you get this area on the bit set to the right, okay? And that seems to check out. So I think that's the answer. So we so I guess just write a comment here. So we're trying to like land in the middle. So we're sort of so this accounts. So if it wasn't accounting for the border. Oh, we're sampling from the middle. Yeah, so we sample from the middle bits. Okay, sample from the middle bits to account for the 1 bit empty border. Excellent. So we want to say like this. So use the bit coordinate. Divide by 2, and this gives us the bit set sample coordinate to sample from. Yeah. Use the source. This gives us the destination texture. Okay. Okay. I think that makes sense. Hey there, Nate Gullis. Thank you so much for the raid. Appreciate it. How's things going? Thank you so much, raid. Welcome. How did the stream go? Yeah, so if the stream crashes and dies, I'll be right back. You know, draw AMD drivers, but it should be fine. TM. Right, still running. So if we check this texture now, it should be correctly downsampled, which would be legendary. Here we go. No outputs. Oh, it's in the middle. It's in the middle, folks. I don't know how correctly this is downsampled, by the way. We've just filled in an area. But there's the other MIP. And you go down. Right, that one didn't even show up at anything. But it could make sense. I don't know yet. I haven't analyzed the data enough. Wait a minute. That's misbehaving around the Z. It shouldn't be at 15 there. Something's up on the Z, damn it. Yeah, the Z axis is a little bit off. That might be why it's disappearing. But at least the X and Y is better. Right, so the thing is that the Z isn't repeated information. So the Z isn't repeated in this sort of 2x2 in this 4x4x2 bit says. There's no repeated information. So you just want to grab the middle bits always. So I think the Z you want. So if I want so if I've got Z axis, so Z goes into the screen. If I've got Z axis, fine, awesome, good to hear. Good to hear. So if I've got Z axis, whatever goes into the screen, right? So 0 is going to be the first one. 1's going to be the same one. That's not right. 1 needs to be the next. What? Bit skeptical here. Oh, we need to do 2 samples. Yeah, we need to do 2 actual samples. Damn it. Another problem. It's a bit like what we did here, and we use it in a bit. Yes, we need to mod along the Z. Use that as an offset, and then do 2 samples. And read from... Is it always 2 samples, though? There's no repeated information along the Z, and we just do 2 samples instead. There's no repeated information along the Z. We just do 2 samples instead. Oh no. It might be able to just be 1 sample still. So if you got this XY position and we're speaking in Zs here, the first, if you're trying to fill in this in the new source texture, which downsampling to 0 as 0Z, you're going to get the 0 give you 1Z. 1 divided by 2, we get you 0. Yes, you read from the 0-bit set and read this area. That seems to make sense. Then the bit behind it, that'll be wait a minute, so it's the 1 border. Yes, that'll be 1. Okay, so the bit behind that'll be in the next texture, or the next bit set. That'll be 2 divided by 2, which will get you 1. And then 3 divided by 2, which will get you 1 as well. Those both read from the same bit set. Yeah, they'll read the same 2 by 2 by 2. Like the exact same bits. So we'll repeat the information. That's not right. How should it work then? It should just read the whole way. I think that's right. So you should just say, oh, by the way, this .z is equal to dispatch index.z. We don't repeat information. We don't repeat the z-axis data. We don't repeat the z-axis data between the bit sets. So this represents a bit we're trying to fill in. It should just be the regular dispatch index, right? 0, 1, 2, 3. Yeah, I think that should be right. Might just have to be take 1. The border. So just take 1 for the border. I think that's right. Wait, no, it's just take 1. What we're doing. It's not a vector. Yeah, so this xy coordinate with 0x will never be a thing because we're not going to be filling that in because there's a border there. Guard this so we never fill in the 1-bit empty border, right? So 0, 1, Z. We'll sample from completely different bit sets. That makes sense. So 0 will, yes, yeah, so sorry, 0 won't happen. 1 will go to the first bit set and look in the middle. There's a border there though. There's literally a border there though. So you got to look across 2 bit sets. Isn't that right? You look across 2 bits. Hang on a minute, we didn't do the border. No, we added 1, so we have got a border in there. Yeah. Do you actually need to sample 2 of these boys? Add 1 along the Z. There'll be a bit along the Z that's not set on the first bit set. So everything is offset by 1, which means you need to sample the 2 4x4x2s and get I need to do something like this again, basically. Oh, where is it? Right, let's copy this. This is in the future. We'll be doing this. So we want 2 bit sets. The first bit set is just going to be hard coded. Is still going to be the 0, 0. So basically, like, six is equal to that, right? So there we go. I need to put a good comment here which describes what this is actually doing. So we're checking for both the source bit sets. So source bit set 0 equal to pass bit set 0. And, right, 1, 1, 1. There we go. So guard this so we never fill in the 1 pixel empty border. So essentially we sample we're grabbing, probably put this thing here, sample the middle bits. Not really middle bits anymore. The middle 2 by 2 bits along the XY, and the last and first slices from the last and first slices of this of the 2 bit sets, source bit sets, to account for 1 pixel empty border of the data. Whereas here we'd put a comment saying, hey, this is the 2 by 2 middle XY bits at the last slice, right? And this is the 2 by 2 middle bits, XY bits at the first slice. We just check if those are set. So I think that's the answer. We'll see how well that works. Just got to get compiling first. Need a comma. Alrighty go. So yeah, if the stream crashes, I'll be right back, but it should be fine. Okay, let's bring in the so it has got a little bit slower down sample, but not massive amounts. That used to be 9.1, but then that's 9.7. Because that's doing an extra sample and it's a bit, yeah, a bit weird, but it's cool. Right, so here's the data. Right, so that shrinks all the way at the end. So this feels correct. Here's MIP 0, which is the biggest one, right? We got this sphere that's sitting in the middle of this 3D volume, and each bit represents a cluster. So the volume is 256 cubed, but we only need 65 cubed, or 65 cubed, where each bit represents a cluster of 2 by 2 spheres, and we have a 1-bit border as well. So as you go through the slices, oh, what the hell is that? What happened there? That doesn't look good. Is that there before? No. Something buggered that up. Right. This one messed it up. It overwrote data. Well, good is it? But it wrote this one in just fine. Maybe. Or maybe not, considering it wrote somewhere else. Something's weird. Uh, oh, this is 32. There doesn't need to be a divide round up, so it should be a flat out divide. Right, that's the problem. Don't worry, I got it. I'll do it. That should fix the problem. Radio, so we're just gonna... Alright, so here's this one. Now let's get into the right place. Let's go down to 1. Still over it. Shouldn't be possible. Your destination is 1 plus. You're launching 32 cubed, right? 32 cubed. So each thread, right? So if you're getting your group index, you're just going to land within the texture. I don't see what the issue is here. Oh, this is being set to the right thing, right? Oh, damn it, there's no bloody overlap on it, you bugger. There's no sync code, that's why. Maybe. That could be the problem, I don't know. Double check that. Okay, let's get to the right place. So MIP0 does get overwritten? Still does. I don't know whether this history thing works for compute. No, just non-compute only. Number of dispatches are fine. Number of dispatches are fine. We was looking at this one at. So we're starting off as 1 plus. And then we're adding 1 to each, so that should be fine. So the source, if you check out the source, so it introduces this problem for some reason. It introduces that. For whatever reason that is, right? You're writing out to the, like you're literally using the group index. So How can this be touching the source when they're distinctly set to something different? Huh. I wonder what it could be. There's 16 slices. Right, it could be the Z coordinate. There's 32 slices, right? 31. Yeah, 32 slices. So, what happens here, which is wrong? Right, we're in 32. No, it's fine. I'm pretty sure. Let's take a look at the. Well, the texture's right here, isn't it? It's got 32 slices and that, so yeah, it should be right. So the initialization code here for it is. Yeah. Base 1. Based on one that makes sense. That's the occlusion MIPS wrong one, but yeah, same thing. Ugh. Ooh, I didn't put the synchronization code down. That's using occlusion, not occupation. So that's the old occlusion buffer, which was tested out before. Copy paste. So it could be a sync code problem. See how that is. Alright. This has to be it. Here's the texture. It buggers that one up still. Pipeline. Barrier. Comment. Image. Read, write on the same one, yeah? Good. Read, write barrier on the map. Excellent, that's what you want. So the sync code is there. This could be a read out of bounds. Like, you'll be getting how many? Z minus 1. So you're getting times 2 on the Z. You'll go, you 32 times 2, take 1, they give you 63. That seems pretty fine because there's 64 or whatever. In the higher resolution one. Um, hmm. So the easiest thing to do is the following, right? You basically write all pixels out and just see what happens. This is the best thing we can do. We just set and just see if it covers the whole thing in red or something like that, or right at 0 or whatever. Let's see if it messes with the previous thing. And if so, it's an addressing problem, but that's still, I'm not sure what this is. Because here, it's all fine. But now we've ran this code, which made this all red. It made the other one like, it made it mess up here. I don't know if this is a bug in. I don't know if this is a bug in RenDoc. It can't. So that last one is not actually needed. There's another MIP there. I don't know if we need that. That should actually be take 1. This could be the problem that it's overflowing. No, it's not. That's not. There's definitely take 1 needed there. There's no doubt. There's that final one. This shouldn't be here. But I can't imagine why. Okay, what happens if we just don't do this code at all? Does the problem still happen? So you click here, you go, you go past about this one here. Right. This seems like a bug. I'm not doing anything here. Like, this thing just finished. This feels to me like a bug in RenderDoc itself. And I don't know why. I should probably update RenderDoc then. Like, because all this shader does when it generates the occupation map, it just writes information. So, sorry, it just bit-ors information. So the only thing it will be doing is creating more data. It would never be taking that away. So there's just must be a bug in that then. So if everything looks alright, I think we've got ourselves a downsampled occupation map then, which means we'll be able to move on to doing this refine LOD, which simplifies the tree. Actually pretty cool. But let's just double check the data one more time. So, right. So let's go down here. Here we go. So this is the first down sample. So the sphere shows up and it buggers up here. I don't know what that is. I don't know if that's a problem with render doc, in all honesty. Something is very fishy there. What is going on? Could be a driver bug. I don't know. Because it's... I would like to think it's not a driver bug. We're not doing anything complicated, right? Sprites and bits out. We're just effectively loading and storing from textures. There's some bit operations. But yeah, maybe we can, like, I can pick a certain location and print it out and see if it is actually, like, what is it, right? So we can try that. So what was it, 32? Right. The 32. Oh, not even that. Okay. Let's say 20 by 20. Oh, it is 20 by 10. Right. At slice 14. So we're just going to do something like if dst bit set coord dot x equal 20 by 10. So y equals 10. Z was 14. So we can, or 13 will just be 14. Then we do our print statement. And we're going to print out like found pixel to a super lovely bit set. See what we get, right? Interesting. All bits are on. Right, we can double check this. 20, 10, 14. Right. 20, 10. Okay, 21. Okay, 1. Okay, whatever. Yeah, 14. So let's give it the benefit of the doubt that the coordinate system's messed up. It's the y's flips the other way or something, right? Let's give it the benefit of the doubt that that's wrong. And let's make the y be 20 instead. Wait, is that right? 32 take 10, isn't it? So that'll be 22. And let's see if we get the same result. We're still all bits on. So it's fine. It is really fine. in the down sample here. This one's not showing anything though. The problem is when I start doing the other ones, we'll see the sharp twice, but maybe that's okay. Let's do 16. It's in the middle of 16, right? 888. It's dead in the middle, 888. This will show up twice because the downsample shader will be called twice. Yeah, I think RenderDoc is messing up. Right, so the first one that printed out was 0. The next one was 1. Why would it be that way around? Surely the first one that gets printed out. Yeah, I think RenderDoc's messing up. It feels like it is because when we wrote out the value, this one at least, it was showing there was a pixel on. Oh, so the coordinate at 15, at 16, 16. Wait, was it? Sorry, is it 888, wasn't it? Yeah, so at 32, yeah, this 132 by 32, at 8, slice 8, offset 88, doesn't have anything on, and that's correct. Excellent. So then in the lower MIP, yeah, it's all on. So that's in the MIP 2 at slice 8, which is dead in the middle. So it is actually there. But for some reason in RenderDoc it's actually wrong. Now, I'm not going to knock this software because I'm using this development build, which is custom patched with a bug of mine, which got fixed. So really I should just get the latest one. So yeah, I'll look into that one. But that's something to know. So I'll get that sorted out before next stream. So it's probably safe to say that we've now got this occupation map working, which is awesome. So this now means in the next stream, we're going to work on this refined LOD shader. This is the next big complicated shader. The basic idea is we go over the highest quality. We start the leaf nodes. We go over the highest quality set of clusters, and we just traverse up the tree. And while we're traversing up the tree, we look to see if a node has any children, and we use this bit set that we've been making to see if it's completely surrounded by other clusters, and if it is, we can then basically like remove this child. Basically remove the child, and then like we basically put a sphere there or something like that instead. Something like that. I need to read over the shader again and make sure everything is good. And there's comments in the right places. Speaking of comments, did we yeah, I sorted all that out, which is good. Wait. We don't repeat the x-axis between the bit set. So just use, so just take 1, so just -1 for the, to account for the border. Not that, no. Since we sample in the middle. Something like that. Right. So after this sort of refine LOD shader, which is the one we're working on next stream, we should get that up and running. There's one more shader to do, and that's basically we need to somehow allocate some memory. I think we'll skip that, but we're essentially going to be copying it from this sort of temporary build memory, right, which has max allocated regions, into like a sort of more compact sort of location in memory, because basically you'd have built it out, simplified it, and then realized, hang on a minute, this is only this many, it's only this big, so you can like move it into a place, into the persistent place, and that's pretty simple shader, to be honest. It's just copying nodes into a more compact area, and then after that we can start getting this thing plugged in. So definitely coming together. We're starting to see things visually in debug tools, but that's all good. Right, so I'll get this up on the GitLab for those who are supporting the stream. Thank you so much. If you'd like to play with the code, it is available via linking the Twitch account or the Ko-Fi account and supporting via one of those two places there. I'll next be on Thursday at 7:30 p.m. GMT. And what else? Yeah, I think that's about it. So where's somebody's raid? I don't know how Kanji does this. He would just stream himself coding, but he'll just be like behind the camera. He'll be in front of the camera and his screens are like glaring. I just don't understand. I don't understand. I have no idea. Have a good night. Take care until Thursday. You too, man. You too. Thank you so much. Yeah, I'm just gonna go and eat some food, exercise for a bit, and then I'll knock out in bed. Right. Thank you for coming on. I'll see you all on Thursday, if not Sunday. And yeah, have a good tomorrow. Good Thursday. I'll see you all later. Catch you later.